Hey guys, welcome to day, 21 of Codeforces every day until GM. Today we're gonna do this Div 3 contest that I'm not the most prepared for. I did not get enough sleep last night. I should probably clean my glasses while I still have the time to do so. But yeah, yesterday there was a power outage in my apartment. I guess the winter storm is actually doing something. It was not out for too long, only like maybe two hours max. But yeah, it was definitely a kind of weird period where we weren't too sure when the power was gonna come back on. It said they were gonna fix it like the day of, but then it said it was gonna fix it like today, at midnight. It ended up happening the day of, so that's cool. We have electricity to do the contest. We have the heat on because it's cold. It's like never been like, well, it's been this cold before, but like it's not a common occurrence where I live. So anyway, we got 30 seconds left until the contest starts. Let's try it. Oh, let's get VS Code open. What am I doing? But let's try to get a good uh 3 questions done this time. But yeah, 3 seconds. Let's do this. Okay. Two one nine three A and the array. My hands are so cold this morning. Typing's kind of slow. Rating. Don't know. Okay. DBMB has a birthday party yesterday. He was gifted an array A of n elements and a number x, but there's one problem. He only likes arrays where the sum of the elements equals s. To make the array appealing to him, you can perform the following operation any number of times. Choose an index and add x to number AI. For example, 1, 2, 3, 4, 1, 2, 3, 5, and x equals 2. You can choose index 3. Okay. What is x? Your task is to determine whether the array can appeal to DBMB after. Okay. Each test considers several cases. First line t equals test cases. First line of each test case contains for underscore in t range t n s x equals int map int input dot split. Second line of each test contains n integers. Okay, so A equals list map int input dot split. Okay. If they can appeal to DBMB, output yes, otherwise no. You can output each letter in any case, yes, okay. So, BMB had a birthday yesterday. He only likes arrays where the sum of the elements equals S. Okay, S is the second number. So we can take index 3 and add 3. And take index 1 and add 1. Index 2 add 2, right? That's basically what it means. So since the sum of these is 3, in the second case, A2, so index 2 add 2 gives us 4, 1, 4, 3 equals 8. So yeah, test case 3 gives us 1, 3, 3, 1. Wait, so index 2 gives us 2. Choose an index in x to the. What is x? X, oh, x is this number. Oh, I see. So it's not according to index, it's according to s. So for this case, we wait, huh? S. So this case is obviously we added 2 to these. This case is obviously we didn't add anything. This case is we added 2 to. Okay, I see. This isn't that hard. So in the for loop, we're basically determine if the array. Okay, let's see a no case. No, 7. 1, 2. If we add 2, it's 3, 4, 5, 6. There's just no way to get 7. So what's the answer? Let me get out a whiteboard. So I think it's just sum A sum A. So S minus sum A equals remainder. And then it's the modulus of the remainder with x equals 0. Wait, if the modulus is it the modulus? Is it just No, I don't think this is supposed to be the case because we're given 6. To this case, we're given 4, 3. In this case, we're given 16, which isn't possible. For this case, we're given 10. It looks like we can do this operation any number of times. 90. 90 divided by 5. 0. So it's whatever's left. 4, 7, 9, 10. It's the remainder mod x equals 0. I think that's it. So sum A equals sum A. S, okay, check, equals S minus sum A if remainder, mod x equals 0, print yes, else print no. Okay, so yes, yes, no, yes, yes, yes. So this case here, we're given 16. Or 15 minus 16 is negative 1. If remainder is less than 0, print no, because it's negative. Hello, copy. And yes, yes, no, no, yes, yes. Wait, what? Oh, break. Jover. Oh, continue. Yes, yes, no, no, yes, yes. There we go. Took a bit long there. 13 minutes. For problem A. Shouldn't be in queue for 10 minutes again. Okay, we'll just move on then. Reverse a permutation. 2193b reverse a permutation dot pi rating question mark. Let's go. A permutation length n is an array consisting of indistinct integers from 1 to n in arbitrary order. For example, 2, 3, 1, 5, 4 is a permutation, but 1 to 2 and 1, 3, 4 are not. What does that mean? Length a consisting of indistinct integers from 1 through n in an arbitrary order. Okay, you're given a permutation p of length n. You can perform the following operation exactly once. Choose two integers LR, reverse the segment in the permutation. Output the lexicographically maximum permutation that can be obtained by performing this operation. The permutation A is lexicographically greater than B if the first position I, where they differ, it holds that A is greater than B. Okay. Input contists. Okay. So test cases T equals int input. Second line of each test case contains for underscore in range T in equals int input, and then P equals this map int input split. It is guaranteed that the sum does not exceed. Okay. Output maximum permutation that can be outputted. So best segment is 1, 4. After reversing, okay, for the second. Test case best segment is 2, 1, 2, 3. Okay. So this one, best segment, this is the best segment. This is the best segment. Okay. So a permutation is an array consisting of n integers from 1 through n. Okay, so I think we just assume it is a permutation by default. And then we want to greedily swap the largest number with the first value, right? So we need to find the max element in the array. And we can do that by what if there's there's not going to be multiple there's not going to be duplicate values, right? So max p equals max p, and then max index equals p dot index max p. And then now the question is, how many times can we reverse? Exactly once, okay. So how many numbers do we reverse? Max p. So we can't just look at the maximum because of case 2. It's kind of difficult. At least we got problem 1, which is cool. Now, like, where do we even think about starting this problem? We're allowed 1 reverse, so what's the biggest possible reverse we can do? 2. So we need to find the first index where it's not already optimal, right? Like in this case, it's index 1 or index 2 in Codeforces terms. In this case, it's not already optimal from the start. So it's for I in range in wait, so the first index where the permutation is not already optimal. The best value we can put there is the maximum value in the subarray. So given array 3, 1, 2. Since this is optimal, we look at the next. Alright, 1, 2. And then we flip. Okay, say we made this, so we did like 4, 1, 2, 3. We start, this is optimal. So the flip is just max of this subarray, right? Okay, say it was 3, 2. Yeah, it'd be Max's subarray, and we find this index and swap. And then we'd move on and then swap 2 and 1. Wait, we can only swap once. Okay, so yeah. So we gotta start for I in range in. Max, call it cur. Cur max is equal to maximum of p from I to n if pi is equal to cur max. Continue. So if it's already optimal, we move to the next number and check. Otherwise, we would have to Okay, I'm trying to. If I do an operation like get index inside of this array, it's gonna be in squared, and that's no good. So let's see, what can I do? Mm, mm, okay, how can we? don't know, I'm kind of stuck. Hmm. Mm. Okay, so we're looking through. Okay, here's my issue right now. This is O of n, right? And this is O of n. So this is an O of n squared operation, so I don't even know if I can do this. Like, we're computing the max every time. Well, We need to like cache the max somehow, I think. Like we need to pre-compute it and then like pull it later when we're checking this. Let me think. So we can store an array where it stores the largest value in the array from the given position to I, or from the given position to the end. So say we were given like 1, 2, 3, 4 at index 0, 1, 2, 3. So at index 0, value would be 4. At index 1 would be 4. 2 would be 4. 3 would be 4. Because the largest value from the current index to the end. So if we had something like 5, 1, 3, 2, 4, the largest value for index 0, 1, 2, 3, 4, and for index 0 it'd be 5, for index 1 it'd be 4, index 2, 4, yada yada yada. Right, so how can we implement this array? We can okay, well first we need to define an array. What do we call this? Like largest. Let's call this Well, okay, what is it? It's the largest value in the array from position I to the end. Right, so like a suffix, it's the maximum of the subarray. We call it like submax. Also, who is messaging me? I just realized I got 2 Discord messages. Submax equals, okay, so we define it 0 and then length n, and then the last element in submax should be like submax -1 should be the last element in p -1, and then we can populate this like backwards. So for I in range, and then since we've already populated the last digit, we can start from n -2, start stop, step, stop when n is -1, and step we increment backwards. And then submax is equal to the maximum of the current, or the current value, which is p I, or sub max I plus 1. Right. So we start from here, we log this, and we go here, n -2. So it's the maximum of these 2 values. Go here, maximum of these 3 values, still 4. Go here, maximum of these 4, 4. Go here, maximum of these 5, which is 5. So this submax array should be 5, 4, 4, 4. Okay. Now we iterate through, and if submax I, so if p is equal to submax, then we just continue. And then and then what? So what this does is it finds the first index. So we're continuing if the first index is already maximum, right? So in this case, we have 5, 1, 3, 2, 4. Our array is, our sub max is 5, 4, 4, 4, 4. So this is good. We continue. This is no good. So we find the rightmost position of submax, which is here, and we swap it with the current. Right, so how do we find the rightmost? j, so we can do if I does not equal to submax, then we can define like variable j equals, oh, what is this? In problem C, queries are independent. That is, when you perform operations on array with a single query, do not. Okay, let me copy this and like put it in a notepad or something. Let's just go here and cool beans. So j is equal to n minus 1. While pj is not equal to submax I, then j minus equals 1. So we look from the right until we find it. If we find it, then this loop ends, and then we just reverse, right? Pi j plus 1 is equal to reverse p ij plus 1. And then print p. Right? Copy. Jover. Object is not, what does it say? Subscriptable. Oh, submax I. Right. There we go. 4, 1, 2, 3, 3, 2, 1, 4, 3, 2, 1, 2, 1. Okay, I need to do star. 4, 3, 2, 1, 3, 2, 1, 4, 3, 2, 1. Okay, I think that's it. Well, this question was low-key hard. We're gonna start. We're basically caching the max first, right? Okay, just do the next problem, I guess. While this is in queue. So what did they say about this? Let me generate the question. First, 2193C, replace and sum. Top high. Today KQ has an exam at the Grail Academy. A strict teacher gave a task that KQ could not solve. He was given two arrays, B, A and B linked in. KQ is allowed to perform the following operations. Choose index, replace AI with AI plus 1. Choose index, replace AI with BI. Okay. So now he has queries. Each query is decided by two numbers LR. His task is to find the maximum value of some. Okay. For each query, if he can perform any number of operations on any elements of the array, since he's not skilled enough for this, he asks for your help. Okay. First line contains two test cases, N and Q. And then second line, first line contains test cases. So just do this, then tab, kill this guy. And then second line is A equals list. Third line is another list. And then following Q lines contain two integers. So for I in range Q, LR equals this. That should be all the input. It's guaranteed that the sum of the values of N and the sum of the values of Q does not exceed this. Maximum values of the sums. He is allowed to perform the following on the arrays. So what they say, the queries are independent. That is, when you perform operations on the array, these do not affect the state of the array before the next query. Okay. Makes sense. So let's see the note. Consider the first test case. Have these two arrays. Where's Q? Q is the number of LRs we're given. Replace A3 with B3. So 323 replace A2 with A3. 333. The sum A1 plus A2 plus A3 equals 9. Okay. So what's he asking? He has Q queries. Each query is described by two numbers L and R. His task is to find the maximum sum of the A thing after doing his goofy replaces. So choose an index I and replace AI with AI plus 1. Now, can you do this any number of times? Let's see. 1, 1. 2. Because we replace A1 with B1. And this one, 17, 16 is from L to R, so we're summing 1 to 2, these two. What we can do is replace A1 with B1, so it's 9. Wait, why is it 17, not 18? Choose an index I and replace AI with BI. So I replace 6 with 9, and then we replace with I plus AI plus 1. So wait, what's the operation for this that gives 6? How do we get 17? I understand for the second one we get 16 because 8 and then 8 and then 16. But this is it's 9. How does this turn into 8? Well, I guess 8, 8, and then 9. We get 17. So, what am I supposed to do? I need to reverse. I can do these operations. So, queries are independent. These did not affect the state before the next query. So, would be a wrong answer on test 2. Let's fix that first before we continue. This is good, no? 3, 2, 3. This. Wait. Four, 1, 2, 3. 3, 2, 1. Huh? Getting a wrong answer. What cases could I have missed? Well, oh, also, like I should probably brake after I reverse, right? I should probably check with these results again. Okay, yeah. Well, it would fail with something like 1, 2, 3, right? Or okay, what do 1, 3. No, no, that passes. Uh, one, 4, 2, 3. Well, that didn't matter. Well, I'm not sure what cases. I would fail. Wrong answer. I gotta wait for Q for 10 bazillion minutes again. You know, what is C about, bro? Like, I don't really see the trick to it right off the bat. So we're allowed to copy from the right. What are these two operations? We are allowed to I'll make this blue. I is equal to I plus 1. We're allowed to do that. And I is equal to bi. That's what we're allowed to do. Why is it? You be blue. These are the two operations we're allowed to do. We can do unlimited operations in any order, basically. Alright. So, yeah, like in this case, we can set this to 8 and then copy all these to 8 if we really wanted. So, if we were to try to maximize every value in A, it would just be the maximum of B or A. Oh, well, we got it. It was the break. Now, I feel like we can do something similar for this problem. Like similar to where you cache the max value, because the max value really all it is so as you iterate through, the max value is either this number, your current number, the current value of B, or the max of A. It's basically the max. So LR well, let's first create an answer array. I think I only need the LRs till the end. We can do the operations beforehand. Alright. Which is just hey, how do we max out an array? We could start from the back. So for I in range in we'd have like current max equals max of AI BI or current max equals max of A -1, B -1, and then we iterate backwards. And current max. And we replace AI equals current max. Print A. So case where it's 1, three, 2, or we do 3, 1 for now. 6, 7, 5, 9, 6, 8. A is 9, 8, 5. A, not, it should be 9, 8, 8. I in range. Input that split failed. 9, 8, 8. Now let's try this one. 1, 4, 1. A is 1, 3, 3, 5. Okay. That seems to work. Now we just sum and start append the sum of the subarray of LR sum A from L to R. Print ands. So we're given 6 instead of 9. That's not good. Should probably print array. 3, 3, 3. Our subarray, our L is 1. R is 3, so L minus 1. Okay. 9, 2, 17, 16. 8, 7, 4. Okay, this seems to be it. Print and star ands. Copy 8, 7, 4, 17, 16, 2, 9. Okay. In Q, we got an hour. So we got problem D. Monster game. Ugh. 2193D. Monster game. .py. $800, or not 800, it's question mark. New game, Elatia. In the game, you're given in swords, each with its own strength in particular. Sword number I has strength of AI and levels, each of which features a monster. Start at level 1 and progress further to pass level I, then move on to level I plus 1. You need to defeat monster at level I. To defeat monster at level I, you need to deal it BI sword strikes. Swords are very fragile. You can deal 1 strike before they break. If you complete level N or run out of swords, you can finish the game to proceed to score calculation. Before the game, you're allowed to choose difficulty. If you choose difficulty X, swords with strength less than X will not affect the monster. Your game score in this case is equal to X multiplied by the number of levels completed. Your task is to choose difficulty maximize score. Okay. Copy this input over. First line in second line A, third line B, so this. I got a TLE on the previous problem. Jover. Where does the TLE out? Maybe here? Might actually be here. Because we're recomputing sums. Can we do like some... Maybe we can do like some sort of prefix sum array. Because we're recomputing the sums every time. Like, I really don't see how we can optimize this further. Like maybe... Because this is... Oh, I'm just simulating here. Right. I don't actually need to simulate for the values I don't care about. But I need to look at the values after. Values before don't matter. No, I think this is fine. I think it's actually sum, because worst case it's O of n. So we can do like a prefix sum array. Like times n plus 1. And for I in range n, pref sum I plus 1 is equal to pref sum I plus AI. And then instead of calling sum in this loop, I can do pref sum R minus pref sum L minus 1. Right. So we cut out some. I mean, if this doesn't work, it's something to do with this, but at that point, I'm totally lost. But okay, this is good to know. Prefix sums is definitely something I need to do more of. Speaking of do more of, what is this question trying to do? Got another TLE. Damn it. On test. Wait, oh, no, it's the wrong status one. Stealing Q. So, monster game. Have in swords. Wait, is A the number of swords and B the number of monsters, or what? You're given in swords. Yeah, A is the strength of each sword. And in levels, that B is the health of the monster, or like sword strikes or whatever. So to break after one strike, we can choose a difficulty. Okay. So if we choose higher X, fewer swords work. But we get a larger multiplier, but we might fail early and get an even smaller multiplier. If we choose a low X, we can use more swords, which means more monsters killed. But it really depends on the multiplier. Oh, and look, we got C. So basically, higher difficulty, bigger multiplier, but chance of failure is higher also. Low, fewer or lower X, fewer swords, lower difficulty, but smaller multiplier. We'd rather have I don't know optimization problem. So to complete a level, you need at least BI. So to complete level I, you need at least BI swords with strength greater than or equal to X. You need to find a way to find the best X. Well, we can sort the swords. And then optimal difficulty, which is 3. You can deal strikes with swords number 2 and 3. You can complete the first level. Wait, what? Why is this one? Okay, swords, monsters, right? You pick 3. You beat the first monster with the second sword. And you beat the second monster with the third sword, no? To defeat the monster high, you need to deal it BI sword strikes. I don't get it. Why is this not 6? I see 2 swords, I see 2 monsters. If you pick 3. Oh, I guess if you pick 3. Oh, is it? Less than. So if I pick 3 swords, is it 3 and less, or with a strength less than 3? So 2 will not work and 1 will not work. What? You can deal with swords number 2 and 3, yes? With 2 swords you can complete 1 level. Here, let's just look at the next case. We pick difficulty 2. Yes, then this one we pick difficulty. What do we pick here? 3, 4, 3. The output was 3, so we picked 1. Yeah, we would be able to kill these 3. If we picked 2, don't we kill this one? with these two, this one with this, you would get 6 instead of 3. I don't get this. I don't get this question at all. I don't understand the output cases. Reread. Start at level 1 and progress further to pass level I and move on to I+1. You need to defeat the monster. To defeat the monster, you need to deal its BI sword strikes. Oh, BI sword strikes. So this isn't the health. This isn't the damage of the swords. Each sword does 1 damage. And each sword has 1 durability. And oh, I get it. Right, so this does no damage. This does 1. Kill this guy. So we would select 1 in this case. 1, 2, 3, 4, and you get 2. But the answer is 3. Wait, I don't get it. I don't get it. It's over. Oh, we selected 3, right? And then these fail, and we do 1, 2, and we get 3 points. I see. I get it. So how do we start? Well, first, we sort A. A.sort. Because that will help us find the number of swords that work really quickly. Now, we need to figure out the number of swords we need to complete each level. So it's another prefix sum. Swords needed equals 0 times n. For I in range n. From 1 to n. Right, because we don't want index 0, so swords needed at index 0 is 0. And then prefix, our swords needed I is equal to our swords needed for I minus 1 plus bi. Right. and then score equals 0. Bro, this question's hard. What are our possible difficulties? Our difficulties goes up to I'm trying to think, would you ever want a difficulty that's like 2? Like, that's not a sword value, so like you have 1, 2, 3, 4, or like 1, 3, 4. Would you ever want to select 2? Because like you could just select 3, and the 3 swords were just as fine. And you would never want to select swords greater than what you need. So, what are the sword limits? Selecting greater value sword is always better when you can. You never want to select 2 in a case like I'm talking about, like in a case like 1, 3, 2, where you're skipping a sword value. Like, you never want to select 2, like even if it's large numbers, like 1, 2, 9, 10. You would never want to select 3 through 8, right? Because you could always just select 9 and the same swords would work. Or you would select 2. If you select in between anything in between, the same amount of swords would fail. So you'd rather just select 9. Okay? In case 2, well, we can do bullet points. Case 2 is selecting. What was case 2? I had a case 2 in mind. I don't even remember. It's over. I need to go back to bed after this. Well, I guess like until I remember, I can set up difficulties, or what do they call it? Yeah, difficulty. Oh yeah. Case 2, you would never select a sword higher than you creative never select difficulty outside sword range. So you would never select a difficulty lower than that's bound by the first case. So you're basically this bounds your cases to the sword values. Like your X selection becomes your minimum is min A, and your maximum is max A. Right. So basically, your difficulties are just all the swords and nothing in between. Difficulties equals. We could do like a sorted set of A, and then I guess we just check each difficulty for diff in difficulties. Question is, how do we check this? You would check maximum numbers. The maximum number of things you can complete with difficulty. So uh, For difficulty and difficulties, like, do we just... Uh, so, we need to get the number of swords available, which is number of swords greater than or equal to the difficulty. So, number... Okay, swords available is equal to Python. Count elements greater than specific value. It's like sum one for element in my list if element is greater than 1. Worst case it's in. Okay. Some element in my list. My list in this case is A. A is my value, so A is difficulty is greater than equal to for sword in A. Okay. I'm using sum again. Sum was no good last time. We can just keep it for now. See if I get a TLE. I got 18 minutes left. Bro, I don't think I'm gonna finish this. 18 minutes. Levels. Zero. For I in range. Yeah, I can use I. For I in range N. If swords needed, I is less than or equal to swords available, then levels plus the levels equals I plus 1. Else break. And then score equals X or difficulty. I should have just named it X. Times levels. Well, it's the maximum of this in score. This feels like it's gonna be very slow. 4. Then I gotta print score. Looking for 9 minus. How are we getting 9? Zero, 1, 2, 0, 1. For I in range, and if swords needed I. Nine. How am I getting 9? difficulty is 1. If I pick 1, I can get 3 levels. Is that true? No. If I pick 1, I can get 2 levels. If I pick 3, I can get 2 levels. Is it just I? Levels equals I. But for level 0, no, it's I plus 1. Swords needed. Swords needed 0. Wait, how is that happening? Oh yeah, the first index is always 0. Swords needed 1. Swords needed 2. Print swords available. I ain't gonna finish this problem. I'm gonna spend 10 minutes debugging. Uh, 3. Pick difficulty of 1. We have 3 swords available. We can complete 3 levels? I 0. Swords needed. Fives. 1. Swords needed is 1. Wait, if I is 1, swords needed is 2. One, two, three. Something's wrong with my swords needed array. Swords needed at index 0 is 0. Swords needed 1 is fine range. Swords needed I is equal to swords needed I minus 1 plus BI. Okay. 0. BI is 1. That's not right, it's 2. Because I is at 1, so I need to be on -1. Then this should be correct. Two, 3. Yes. The score is 6. Why is score 6? It's difficulty 1. I have 3 swords available, and I need to complete 3 levels. I need 4 swords. In this 3. Complete 1 level, I need 2 swords to complete. This is in +1. Iron range in +1. Also, how am I getting 6? Like, this one. To complete, at a difficulty 3, I complete 2 levels. It is not possible. Let's see. At a difficulty 3, I have 2 swords available. And I need 3 swords. Print swords available, swords needed. Needed I. Uh, 0. I have 3 swords. I need 3 swords, I have 2, so this one doesn't work. I need 3 swords. I have 3. I should print out the cases that actually pass. So, I need 3 swords, I have 0. Passed? Wait, I have 3 swords available. I need 0. 3 swords available, I need 2. Let's swap these. So I need 2, I have 3 swords available. I need 3, I have 3 available, so difficulty 1, level 3. I need 0, I have 2 available. Have 2. And I need 2 available. Difficulty 3, level 2. I get to level 2. That's not right. I think it's +1. Score 3, score 4, score 3, score 8. Okay, wait, this is actually it. I'm a little bit worried about time complexity. I think this is going to be slow. But it works as an answer. We got a minute. Let's submit it. In the meantime, what can I do to optimize? This looks very slow. Wrong answer, test 1, Jover. Oh, shoot. Okay. 3, 4, 38. Please speed. Now the question is it gonna TLE on me? If it TLEs anywhere, it's here. Yeah, it's Jover. I have 5 seconds. This might be a complete next time type of question. Let's see. Well, we got 3 out of 4 again. Mark this as whip. We'll do this one tomorrow. Figure it out. Alright. Well, I'm not too dissatisfied with this contest. We were able to... Some of these were hard. They all like played around this idea of prefix sums. Like even this one had like a prefix sum. This one had a prefix sum. This one, I don't know what this one was. But I didn't do too shabby. I definitely think I got a little bit better since last contest, which is cool. But yeah, we'll finish up this question next time. Monster game. We'll probably also do the other work in progress that I was doing. I don't know, I forgot what it's called, but I'll figure it out. And yeah, if y'all guys liked this video, please Be sure to like and subscribe. It's a little bit longer video. That's just how contest videos are. But yeah, like and subscribe. I'll see y'all guys tomorrow.